Welcome. Here is a just the basics derivative calculus type problem that we're going to be quizzing on, and we're going to really let you have it on this one. There's a lot of algebra that comes through with this. I might do this in two parts. I have a restricted amount of time right now. So first thing we're going to do on this is we're going to go ahead and find our domain, the allowable values for x. I can put any number I want here. I can square any number I want. I can subtract any number I want from 9, but I can only take the square root of non-negative numbers. Therefore, we know that, I'm just going to use some space over here, 9 minus x squared has to be greater than or equal to 0. And I think we can easily see that 3 is an interesting value for us, as is negative 3. If I set this equal to 0, I get x squared equals 9. So 3, I can put 3 in here, barely. I would get square root of 0. I can put negative 3 in here, I would get square root of 0. A quick test, a number between negative 3 and 3 is 0. I can put 0 in here. So the numbers between and including negative 3 and 3 are the numbers in our domain. So my graph is going to exist between negative 3 and 3. We're not going to go outside of that domain. And then oftentimes it's nice to know the 0, and the good news is oftentimes it's easy to determine the zeros. Zeros of this function, if I put in 0, I get 0 times something. If I put in 3, I get 3 times 0. And if I put in negative 3. So those are my only zeros on this curve. So we got a 0 here, here, and there. My graph lives within. So next we're looking for our derivative. And for the purposes of our derivative, I'm going to write this function as x times 9 minus x squared to the 1/2 power. And we are finding that derivative. So what we have here is a function of x times a function of x, or an f times a g, and g we should recognize as a chain rule. So the derivative is the plain old first function times the derivative of the second. This is the troublemaker. My outside function is something to the 1/2, so this becomes 1/2 something to the negative 1/2. It's the outside derivative, got it, of the inside function, got it, times the inside derivative, which is negative 2x. So that is the first function times the derivative of the second function, plus, this is nice, the derivative of the first function is 1 times the plain old second function, 9 minus x squared to the 1/2. Okay, great, but we're going to clean this thing up a little bit for purposes of where we're heading next. So I'm going to, let's see, I've got 1/2 times negative 2, negative 1 times x, I get negative x squared times 9 minus x squared to the negative 1/2 plus 9 minus x squared to the 1/2. And just as if I had this, let's say I had a to the second plus a to the 5th. I would factor out, I might be tempted to factor out an a squared here and get 1 plus a to the 3rd. That's just a little sidebar. So what did I factor out? The smaller number of a's from each term. This shares a factor of 9 minus x squared. The smaller number of those is negative 1/2. So I'm going to factor out the smaller number. And I'm left with negative x squared plus, what did I do here? I took 5 minus the 2 that I factored out to get 3. So I take 1/2 minus the negative 1/2, and I get 9 minus x squared. 1/2 minus negative 1/2 is 1/2 plus 1/2, or 1. Oh, that's nice. I end up with 9 minus x squared to the negative 1/2 times, I think I'll put the 9 first. I have a minus x squared and a minus x squared minus 2x squared. Or 9 minus 2x squared on square root of 9 minus x squared. That's how I'm going to write this. That has a little bit of meaning to me. So my first derivative is 9 minus x squared, or not, I'm sorry, 9, my mistake, 9 minus 2x squared it was, all on square root of 9 minus x squared. And now what we typically do with that first derivative is we find our critical points where the first derivative is 0. So if I set this equal to 0, cross multiply, I get 9 minus 2x squared equals 0 times root 9 minus x squared 0, or I get 9 equals 2x squared, or I get x squared equals 9 halves, or x equals, careful, plus or minus 3 on root 2, or plus or minus 3 root 2 on 2. So those are the points where my graph levels off. Those are my critical points. So I need some idea of what my graph looks like. So I'm going to put in, these are my only zeros. So I either go up and come back down or down and come back up. If I put 1 in here, I get 1 times square root of 8. That's a positive. So this graph, I'm not exactly sure how it looks right now, but I know it comes up, comes back down. If I put in -1, I get -1 times square root of 8, negative. So it goes down. And I know it doesn't cross again, so it must look something like this. Therefore, I have a maximum, or I'll go with my minimum first. I have a minimum to the left. So my minimum value would be where the derivative is negative 3 root 2 on 2. So the minimum is at negative 3 root 2 on 2. And we could find the y value. We'd have to put it in here, and it would be a bit of a mess for a while. But I'm going to just leave that one as at x equal. Could probably put x equals. So for this one, I'm going to put the maximum is at x equals positive 3 root 2 on 2, as you remember from here. Okay, this is going to get worse before it gets better. The good news on this, though, is once I have this minimum and maximum, I can go ahead and say, well, if this is my only minimum, my graph is decreasing from 3 until this would be at negative 3 root 2 on 2 something. This would be at 3 root 2 on 2 something. So I'm decreasing from negative 3 to negative 3 root 2 on 2, and I'm decreasing again over here. So my decreasing, see if I can get all of this in on the frame. Yep, I'm decreasing from negative 3 to negative 3 root 2 on 2. In union with, I'm decreasing from 3 root 2 on 2 until I get to 3. I'm increasing between the two, between the minimum and the maximum. I'm increasing from negative 3 root 2 on 2 until I get to 3 root 2 on 2. And then the second derivative, that will be on the next video because I'm running out of time quickly here. The second derivative would invite you to try that before you watch the next video. That will give me, when I set it equal to 0, the inflection points, and that should allow me to know concave up, concave down, or concavity. But I'm going to tell you this right now, the second derivative, if you get that before you watch the video, you should feel very good about yourself. There's a little bit of a challenge going on in that one, but I'm certain we'll have some people that can have some success with that. Please give it a try, and I will be back with the second video shortly.